In this video, we'll talk about a bunch of questions on probability, but not the card questions that we will talk in a separate video. So let's talk about some of the die problems. So here is a question. The question is, suppose two dice are rolled. So one dice and the other dice are rolled, and 36 possible outcomes are equally likely, means it's a fair die. Now what is the question is, find the probability that sum of the numbers on the two faces is even. Probability that sum of numbers are even. So we know that there is probability is 2, 4, 6 or 1, 3 and 5. So probability of, and it is half, and for this also this is going to be half. So probability of event and event is going to be half times half, that is equal to 0.25. Probability of event and non-event is also going to be half and half, that is also going to be 0.25. Probability of outcome in non-event and non-event is also going to be half and half, that is 0.25. And probability of non-event and event is going to be half and half, 0.25. So what is the favorable event in that? That the probability of event and event and probability of non-event is 0.25 plus 0.25, that is equal to 0.50. So what it is really even and even and odd, because if it's even and even, it's going to be the first die is even and the second die is even, so you either get a 2 and a 2. But if the first die is a 2 and the second die shows a 1, but then if the first die is an odd 1 and the second die is also an odd, that also gives you a 4. So the two ways you can get that the sum of the numbers are even is either even and even, in which case it will be even, or even and odd, which is going to be this. So the possible probability that the sum of the numbers are even is going to be 0.25 and 2.25 or 0.50. Okay. Next question is, that we have a box which has 10 balls. We pick a ball at random and then pick another ball. Find the probability that the number on two selected balls differ by 2 or more. Probability that the number on two selected balls differ by 2 or more. So to do this, we use the complement principle, which is that the probability that they only differ by 1. So let's see the two the possible ways. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you pick 1 and 2, you pick 1. You can pick 2 and 3, that's 2. You can pick 3 and 4, that's 3. You can pick this, that is 4. You can pick this, that is 5. You can pick this, that is 6. You can pick this, that is 7. You can pick this, that is 8. You can pick this, that is 9. So there are 9 possibilities. Now we are picking 2 balls out of the 10. So how many ways you can pick 2 balls out of 10? That will be 10 choose 2. That is 10 factorial divided by 2 factorial and 8 factorial. That comes out to be 45. So the probability of the event, which has the event can happen in 9 ways, about by total possible ways you pick 2 balls is 45. So the possibility of the event, which is that number differ by 2 or more, because if they don't differ by 1, then it's going to be differ by 2 or more. It's going to be 1 minus 9 over 45, or 4 out of 5. There is another way you can solve this question, that the 2 balls differ by 1 only. So here we have picking 1 ball, and we have 10 ways to pick 1 ball, and then we have 9 ways to pick the other ball. So there are total 90 possibilities, and there we know that there are 9 ways to pick 1 ball and then the other, so the difference is 1. But here is the catch. The catch is that you can pick ball 1 and ball 2, or you can pull ball 1 and ball, but the number doesn't matter. So in fact this becomes 9 times 2, or 18 ways you can pick these balls. So the probability of event becomes 18, and the total possibilities here is 90, so 1 out of 5, so which gives you the same number as here. Here you have done it in a different manner. Here you have done it in a factorial 10 choose 2 type of situation. Now we have another question here, which is a bag contains 20 balls. Now here we are selecting 2 balls at the same time. What is the probability that the two numbers selected do not differ by 12? Probability that 2 numbers selected do not differ by 12. So we have 20 balls and we are choosing 2, so 20 choose 2, that is going to be 190. Now look at the number choices that differ by 12. So you have 1 to 20, so 1 and 13 will differ by 12, 2 and 14 will differ by 12, 3 and 15 will differ by 12, 4 and 16 will differ by 12, 5 and 17, 6 and 18, and 7 and 19, and 8 and 20. 1 2 3 4 5 6 7 8. 8. In 8 choices we are numbers do not differ by 12. So these 8 choices we are not allowed. Here the balls are picked at the same time, so it doesn't matter which is first ball. So they are only using 8 instead of the other one where we use 16. So 8 choices we are not allowed, which means how many choices are allowed? 190 minus 8, that is equal to 182. So the probability that the two do not differ by 12 is going to be 182 over 190.